So this is the second video demonstrating the new NGL vertex array object factories, and this demo is going to be using the MultiBuffer VAO. This is very similar to the simple buffer, only this time when we create buffers we can create more than one of them. So if we have a look with a stood unique pointer of abstract VAO, so that we get our destructor scored at the end and all the code tidies up. And again, we have a method which is called in initialized.gl called build VAO. This time I'm just using a stood array for my vertices because it's just a set array and the data is exactly the same as in the previous demo. And what's different this time is I'm going to create the normals in a separate buffer, and then I'm going to have two buffers, one for the vertices, one for the normals. So I'm using a stood vector here just for the convenience of pushing back. So I go through, I grab my vertices from the array, go through, push them back, exactly the same calculations as before. This time now, instead of creating a simple VAO, I'm calling the MultiBuffer VAOFactory. Again, this is registered when NGL is initialized and it's part of the default VAOs used internally within NGL. Most of the time you will use either the simple or the MultiBuffer one. It's only for other cases that I'll show in a later video that you may need to extend it. Again, we need to bind our VAO, and then we can go through and we can set our data. So this time I'm setting my first buffer, size of verts, so that gives in bytes the size of our array, and I'm passing in the first element that will get passed, and a new vertex buffer will be created with all of my vertices. Again, I need to set the generic vertex attribute pointer. In this case it's attribute 0. It's got three elements of type float, and the data is at 0, 0. It starts at the beginning of the buffer, and to get to the next one there's no stride. Now for our second buffer we call set data again. Now in the simple version, if we call set data a second time, the existing data would be removed and cleaned and a new buffer created and associated with the vertex array object. In this MultiBuffer one we actually generate a new buffer, and we can access the buffer data. There is actually a method internally which allows us to get buffer ID. We pass in an index and that will return the actual OpenGL identifiers. So we can bind and access them as we would do in normal buffers quite nicely. And internally the MultiBuffer VAO has a stood vector with these in here, so we can access them, we can bind them directly, and we can grab that data if needed. In this case we don't. So now I'm passing in my normals, exactly the same again, exactly the same size. And we set our vertex attribute pointer, so our input number 2, generic vertex array 2, there's three elements, type float, and again now the data is tightly packed. We then set the number of indices. We can just use verts.size, which will return 12 because that's the size of the stood array. We unbind again, and then exactly the same as before, we bind, we draw, and we unbind. So there's very little difference here apart from the fact that we can have more than one buffer associated with our VAO.